angles are angles that are between 90 and 180. They're more than 90, but less than 180. And then, do we have angles in geometry? Will we ever have angles that measure greater than 180 degrees? Sure, but we don't want to worry so much about, because we're only going to talk about going within one revolution. If I go completely around an object, how many degrees does that make? 360. And we have a couple examples of how something like that can happen today, when we deal with some adjacent stuff and things like that. Okay. And then obviously the straight angle just means that it's an angle that equals 180 degrees. Okay. Less than 90, between 90 and 180, and then equally 90. Again, these are all things that I know you guys have seen. It should not be anything difficult. Yeah, I know. Yeah, they're done that. Yeah, they're done that. That's kind of why one of the reasons why I like to present stuff the way that I do, is because I try to make sure that it relates as much back to stuff you guys have seen. Angle additions. Well, let me go back here a second. So, if I say that angle is 135 degrees. Oh, angles in geometry are measured in degrees. The degree symbol is that little circle dot that you put to like the upper right-hand corner after your digit. Is it the end of the world if you forget to put a circle dot for degree symbols? It's not the end of the world, 'cause I'll forget half the time as well. In Algebra 2, we'll deal with them in terms of pi, which are what we call radians. So that's the same style, but it's more of a standard set for upper level math as opposed to degrees. Again, what's that? Pi? Yeah, it just never ends, does it? What's that? And that's all you need to know, you really don't. So if I say that this angle is 135 degrees, and I say if the whole thing is at 135, and I say that this portion is 35 degrees, how much would that part be? How much? 100. What did you do? Right. You remember the rules of segment addition? Two parts, if they are collinear, they can add up to equal the whole. This is segment addition that just changes direction. Okay? Segment addition and angle addition are basically the exact same thing. When you guys did segment addition, you had to have 3 points that were collinear, right? So we knew that AB plus BC equals the whole thing, AC. Everybody okay with that? What changes with angles then, I'm going to use different letters here real quick. If I use X, Y, and Z, and then I'll put a W here. What is the largest angle here in terms of letters? Use three letters, Angle XYZ, are we okay with that? It's large angles XYZ. What are the two smaller angles that make up angle XYZ? XYW and then WYZ. Notice, when you have angles that share a common vertex, just like how this shared, they were collinear, if the two angles share a common vertex, you can add those two together to get the whole thing. It's along the same idea of what we just did here in a second. If this is 45 and this is 50, what's the whole angle? 95. And that's what we're looking at here. It's no different than this. It's just the only thing that's different is there are more letters. Okay? So with this idea of angle addition, this idea here, what's called angle addition, if I use this diagram here, what's the largest angle you see? What are the three letters that make up the big angle? Angle ABC. Do you guys all agree then that angle, this large angle ABC, let me zoom in a bit. that angle ABD plus angle DBC. And this is where geometry can get kind of messy. There's a lot of letters. Your handwriting you have to try and write neatly so you can understand what you wrote. So now that means if you'll look at the lettering, notice how B is always in the middle. B is always in the middle because it's the common vertex. Where it starts, A to B to D, D, B, and C. That means those outer letters are always the outer letters of the biggest angle. Angle addition is nothing more than segment addition, just with a couple extra letters. Really all it is. And I know you guys all know how to do this. All right. Instead of just being in the segment, which is straight across, you're changing direction. Wow. Okay. That is the only difference between them. Mapping of it is going to be identical. Okay. What's that? Sorry. So again, if I say that the whole thing is 105 and this much is 40, that means algebraically, I don't know what angle ABD is. I'll make it a value of x, but I know that DBC is 40 and it has the equal 105. Taking the geometry vocab of angle stuff and piecemealing it back to a one-step algebra. Okay. And what would you get for that other angle? Very good. Just by subtracting the 40 over, you know that that other angle would be 65 degrees. Okay. Again, if you don't, it depends on the problem. Sometimes the problem will ask you to solve for x. Sometimes it'll ask you to solve for the angle. In this case, x is the angle. Well, let's say it was the variable inside it was like 2x plus 3. Then you would have to do the algebra and then substitute it. Right. Again, it's nothing that you haven't done yet. The only thing that's a little bit different is that angles have more letters. That's it. Okay. You with me so far? Okay. Well, again, we could probably figure this out in our heads. Angle, if I'm looking at this, angle ABC, is that a small part or the whole part?
It's the whole part.
So if the whole part is 110, this much is 35, what do you do to figure out this? Yeah, what do you get? Is it 75? Boy, mathing that was hard, wasn't it? Okay. Again, you don't need to draw all this. I just want to show you guys how things are going to work themselves through. What's that? Oh, did you want to draw? I mean, if you want to draw it up, go ahead. All right. Yeah, and I just wanted to keep showing you guys that there's so many different ways of doing this. Oh, okay. What does that little box mean again? It's a right angle, good. Which means how much does it have to add up to equal? 90. So if one part's 26, what do you do to figure out the other part? Yeah.
You math?
You math it. Very good. That's yes. You have to math it. So if I go to math that, I know that 26 plus something is 64. Oh. Okay.
How do you know it equals 90?
What's that little square box in your corner?
It's a 90-degree angle.
So there you go. Thanks for playing along.
I'm mind blown.
All right.
That's amazing.
So let's try this then. let's throw some algebra in. Okay, take a second to write it out. I don't want to, because I think I have some more of these examples.
Wait, do we have to run this right now?
Yeah, write this one down, because I don't have this one on the slide. All right? Which means we're not playing on our phone right now.
Who's playing on this?
Don't worry about yourself. Worry about yourself. So algebraically, when you go into this one, what are those two angles? If one of those two angles have to add up to equal? They have to add up to equal 78 because angle NRQ is the whole thing. Okay. So if that's going to be the whole thing, as you start putting this together, you know that you can write, just like we did before with segments. Just trim this down a little bit. I know that this angle plus this angle has to equal to 78, so I know that 8x plus 7 plus 4x minus 1 is 78. Yes, sir? If you want, that's fine. And like I said, it doesn't matter if you use the symbol or not. It really doesn't matter to me. Okay. Combine your like terms, just like every other math problem we've done. We get 12x and 6 is 78. Okay. 2 steps, what do you do first? Add 6.
Oh wait, subtract 6.
Good. And then divide by 12. It is 6, good. Now, the question say solve for x, or did the question say solve for something? Solve for something, very good. Again, this is very similar to what we did with segments. Segments you solved for x, and then it said, hey, figure out what BC is. Okay, same idea. So now I have to figure out which angle is it looking for. It's looking for angle PRQ. So I have to substitute 6 into here. What's 4 times 6? 24. Subtract 1 and you get, there you go. Okay. Now, you could always take a second to make sure that the other side works when you add them together to get you the whole. So, yes, sir. Great question. Good. I enjoyed our conversations immensely. What's 8 times 6? Add 7, you get 55. And last time I checked, 55 and 23 add up to equal 78. So. But what you want to do though is, it still doesn't tell you if this value of x, you put them together, if it's sort of equal to that. Just double check. Okay? Again, shouldn't be so bad. Now, this is where things can get interesting. And this goes into the idea of a couple of different angle stuff. And I have this one drawn for us. You don't have to worry about drawing that one out. What's that? No. I just have some examples. I want to do some work with this stuff here. Well, in case you guys hadn't checked your email or saw it, I have a meeting I have to be at today. the anti-flex. Very, very good at manipulating anti-flexing. So, there's a couple of things that we have not really gotten into yet, and I wanted to kind of leave off some of that info to see if you remember some of this stuff. Now, what I like to do, again, this is at the very top of your page where it says the in-class angle fun stuff. Now, when you look at this, there's a whole bunch of stuff going on. Everybody see that? Now, when I go over here, and I'm trying to figure out where's a good place to start, I look at these two. Those two angles created a what? They create a line. Yeah, they create a line. They have to add up to equal 180. If two angles that add up to equal, or two angles create a line, they're called a linear pair. We'll get into more of the what's called angle pair relationships tomorrow. But the idea is, if two angles that add up to create a line, they're called a linear pair, which means if they make a line, how many degrees do they have? How many degrees are in a line? 180. So those two angles have to add up to equal a total of 180 degrees. Well, if this angle is 160, what's left here for angle A? 20, good. So I know that this one has to be 20. Well, if I rotate here now, oops. Oops. What do those two angles have to add up to equal? 180, which means what does angle B have to equal? 160. Hey, that's kind of weird. What would be the other angle that's not labeled then? 20. Now, what happens here is this is another what we call an angle pair relationship, and we'll define this tomorrow. Notice how this is a line and this is a line. When two lines intersect, you get four angles. You okay with that? The angles that are opposite one another, across from one another, are always equal to each other. Okay? That's called a vertical angle. So the 160s are vertical. The 20s are vertical because they're across from one another when the two lines intersect. They will always be equal to each other. Okay? Again, nothing you have to worry about now. When you hear that definition tomorrow, we talk about it, you'll be like, oh, man, you said that yesterday. Okay? What do those boxes mean on the other side? The right angles. How many degrees are in a right angle? 90. Okay? So I have a 90 degree here and a 90 degree here. Now, if I look at this example, how many angles make that straight line? How many angles will make up that line? 3 of them. I have a 90 degree angle plus angle C plus 75 has to be 180. Well, isn't that the same thing as doing 3 segments to add up a whole? Same exact idea. Okay? So what would you do to figure out what angle C is then? And then back it out from, and what do you get? 15, very good. Yeah, another quick, easy way to do it is if it's 90 degrees here, it has to be 90 degrees here. And that's fine. And it isn't the same thing saying, oh, that's 90, bring this over, something plus 75 is 90. See, there's many ways of doing these things, and if you see it one way versus another, there's nothing wrong with that. Absolutely nothing wrong. So you get 15 degrees for that angle C. Well, if this is angle C here, doesn't this line cross this line here? Doesn't that make this one here 15? Which means what's angle D have to be? Exactly. Again, we're using some term stuff that we haven't completely gone over, but I didn't think this was a bad spot to kind of show you guys where we're going to start seeing some other pictures. Okay? Not too bad, right? All right. And the ones right below that, it says, given that XZ bisects. This is a new term. What do you think an angle bisector does? Cuts it in half, exactly. An angle bisector cuts an angle into two congruent equal parts. Kind of like a segment bisector or a midpoint. So if your whole angle is 60 degrees and it gets cut in half, what is each part going to be? 30s. An angle bisector just cuts an angle into two congruent angles. So you'll start to see tick marks within an angle. Instead of the tick marks on segments like we did, we put little arcs to show that the angles themselves are congruent. Kind of the same idea. Now, in this example here, it says that XZ bisects all of those angles. So if I'm looking through, and the first one we have, where this is W, X, Z, and Y. Oops. And if that part's 39, what's the other side have to be? How much? If it bisects, if this is going to bisect the whole thing, that means it cuts it into two equal spots. So if one side's 39, the other side is 39. See what that means? Okay. What's that? No, it really isn't. It really isn't. So if I'm looking at the other one where it has 57 on one side, what's the other side have to be? 57. Now, the next one, it's drawn a little bit differently. And I want to make sure you guys see how this is drawn out. It's W, X, Z, Y. They have the whole thing at 146. Okay, yes ma'am?
Why are there exclamation points?
They're yelling at you. One of the weird things with some of the older worksheets that I have, for some reason when it goes from printing from the computer, the typesetting gets changed. It doesn't mean anything. It's just, if you see an exclamation point, it's not yelling at you. It's not screaming at you. It's not trying to do factorial. You remember what that is. It just means angle. Okay? It's just weird. Now, it's pointing to that entire angle being 146. If the whole thing is 146, what do I do to figure out what each piece is? Okay, so what's half of 146? This should be easy to do in your head. What's half of 14?
6.
What's half of 6? So what's half of 146 then? There you go. Okay. Make it easier than it needs to be. Okay. Now, in terms of the bisector stuff again, if you flip over to the other side, the middle section, I'm going to look at number 16. So if BD, nice say, if BD bisects the angle ABC, that means it creates two equal angles. Right? Which means on our diagram, I know these two have to be equal. So if I wanted to solve this algebraically, what do I have? Bless you. If I have to solve this, What would I do algebraically then? How would I write that out?
4x.
Exactly. Perfect. Very good, very good. I know because of the definition, a bisector creates two equal congruent angles. To solve it algebraically, we just wind up doing 4x is 3x plus 6. Bless you. How do I solve that? Subtract 3x. Good. If I subtract the 3x coming back, you get x is 6. But what does the problem say to do? Find angle ABC. Well, ABC, is that the part or is that the whole? It's the whole thing. Which means I have to substitute in for x in both spots. So I have to have 4 times 6, 3 times 6, plus 6. So what's 4 times 6? 24. 3 times 6, adding 6 to it is also, add 24 and 24 and you get 48. So the angle here, the whole thing, would have to be 48 degrees. Again, when you have a bisector, that means the two angles have to equal each other. Bless you. Okay. Take a second and try number 17. All right, the one right next to it. Take a second to figure that out. I draw that up. Did you get 98 degrees for that one? How? All right. Remember, bisector. Bisector means that it cuts it into two equal spots. So when you look at your algebra then, that means that these two angles have to be equal to each other. So you write it out as a algebra. Subtract 4x from both sides. You get x minus 11 is 1. Finish this backside for this evening. We'll just do this for tonight instead of doing it because we didn't get far enough for me to get into the other stuff that I have. This is the backside. This is the backside. So it starts, what is it? 10. So you have numbers 10, 11, 18, 26, 27, 28. Just the backside of the sheet here, okay? All right. So we'll just finish the backs for tonight. So that would be what? 10, 11, 18. So you've got the two at the top are just straight angle additions. Two smaller angles add up to equal to large. The next four are just bisectors. So if you want to finish the last four, you've probably got time to finish up a couple of those real quick. You're doing the exact same thing we just did in this last problem. Okay. Just the back page, whatever's left there. Usually when you have hole punch on the left means it's the front. Well, okay.